Hello everyone, my name is Sajeen Tandukar. I will be giving a short presentation on my topic, the prediction of chronic kidney disease using ML. My student ID is C7575201. I am the student from British College, which is affiliated to Leeds Beckett University, and the name of my supervisor is Dr. Mais Moharjan. So, a short description about my project is the project is basically a final project for MSCIT, and it is mainly made for predicting any patient is if any patient is on the brink of having chronic kidney disease or not. So let's move on to the aims of my project. So the principal aim of the research was to basically compare multiple machine learning algorithms to accurately predict if a patient or a client is going to be affected by chronic kidney disease down the line. The other objective was to basically gain knowledge on which model best fits the prediction of, or which model best shows the best prediction of the chronic kidney disease given any data set. However, the data set needs to have certain constraints. So if those constraints are not met, chances are the data set or the entire project is not going to show proper prediction. So there's that limitations there. So a small background about this project or why this project was done is basically in the current world, a lot of people are eating or having ultra processed goods or foods. So what this has caused is that the people are starting to get sick, their organs are starting to get damaged quite a bit, and due to this, one of the main organ that gets damaged that I have seen or I have learned about is kidney. However, one of the other reasons, except this, is that kidney disease is something that is quite hereditary in my family. So this was one of those projects that is very close to home as well. So when due to this reason, so CKD or chronic kidney disease is something that is quite widely known and widely researched. However, the prediction models have not yet been properly used on this. However, since technology is advancing rapidly, we are seeing these prediction models used in heart failure or any other heart related diseases, or sometimes in your liver diseases, and all those things are starting to pop up. However, kidney disease is one of those things that have not been properly researched. However, there are a few resources, but not all of them have been used. Not all of them are using machine learning. So moving on, the methodology of this project is basically quantitative methodology, where I am choosing various data sets from various publicly available uh, websites such as Kaggle or UCL. So the main data set I have used is from UCL. Uh, However, the data sets that have been provided are not quite high in number or large in number, so the prediction model needs to be trained a bit more. However, down the line, that is a very future advancement for my project. The next thing that I want to talk about within the methodology is that the main reason quantitative method is used is because the numerical values or numerical numbers that we have, large number of information or data that we have, can allow our model to properly train itself and then test itself whenever any data is provided and give accurate answers depending on the information provided by the users or the clients or the patients. Now, further moving on into the research and outcome decision discussion, my bad. So when the models were trained, since the data set is quite small in size, it was noted that decision tree is the one that gives the highest accuracy. However, one of the other information that we gained is that decision tree and random forest have the same accuracy given the data set. However, in the future, if we are able to obtain more larger data sets, I believe random forest would be the best fitting model with the highest accuracy. As we all know, decision tree is typically used for small scale data sets. However, one of the three models that was used was SBM, or support vector machine. This model at the lowest accuracy of the three. So the image I have attached in the poster design does showcase all three of these data sets. Next, so ethical considerations that we are facing or we need to face when we are going to make any projects are a dime and dozen. However, the few ethical considerations within my project are data privacy, since we do not want the clients or the patient's data to be public or given out freely. We are using publicly provided anonymous datasets that is available in Kaggle, UCL, and other various websites. So this makes sure that the users or the clients or the people who are participating in this training model are not affected, or their personal information is not available to others. The next is algorithmic bias. So we do not want the algorithms to be biased. So the models will be constantly monitored. Whenever new data set is provided, the model will be monitored properly rather than just being said that decision tree is the best or the RF is the best. So that's the ethical considerations. So lastly, I would like to say that the conclusion has shown that basically we have successfully trained three different models. However, depending on the data set, the models showcase various different types of accuracy. As the data set is quite small in my case, the data set being small has made it so that the decision tree is the one that is the best fit. However, in case a larger data set is provided, we will be able to showcase that maybe random forest is the best. However, SMEM has shown that it has the lowest accuracy among the three. And lastly, I would like to thank Dr. Moise Morrison, who has been a key person to allow me to understand what my potholes can be in the project. He has made sure that we do not derail out of our aims and objectives or what we wanted to do throughout the project. So, with that said, I would like to close my presentation here. Thank you very much.